Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here is some information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. Losses due to accidents at an amusement park are exponentially distributed. An insurance company offers the park owner two different policies with different premiums to insure against losses due to accidents at the park. Policy A has a deductible of 1.44. For a random loss, the probability is 0.640 that under this policy the insurer will pay some money to the park owner. Policy B has a deductible of D. For a random loss, the probability is 0.512 that under this policy the insurer will pay some money to the park owner. Calculate D. So the important thing to notice immediately, please note that, is that the insurer will make a payment to the park owner if the loss exceeds the deductible. Losses are exponentially distributed, so in theory there is completely no upper bound on the losses, but the losses have to exceed the deductible for some payment to be made. Therefore, under policy A with a deductible of 1.44, 0.640 is the probability that the loss exceeds the deductible. And under policy B, 0.512 is the probability that the losses exponentially distributed, and it's the same distribution for either policy. Losses exceed D. And here's the solution. So let's write x for the exponential random variable considered and lambda for its hazard rate. Then probability that x is more than 1.44, which is the survival function of that exponential distribution evaluated at 1.44, which is e to the minus lambda times t, where t is the value that we're exceeding. In this case, that's 1.44. So this is e to the minus lambda times 1.44, or e to the minus 1.44 lambda. And we know that this is 0.64, or 0.640. Also, we know that 0.512 is the probability that x is more than d, which is the survival function of x evaluated d. But that's going to be equal to e to the minus lambda times d, or e to the minus d times lambda, which is the same as e to the minus 1.44 lambda to the power d over 1.44. But e to the minus 1.44 lambda, from what we stated just above, is 0.64. So this is equal to 0.64 to the power d over 1.44. Then if we take the natural logarithm of both sides, we get the natural logarithm of 0.512 equal to the natural logarithm of 0.64 to the power d over 1.44, which is equal to d over 1.44 times natural logarithm of 0.64. And therefore, d must be equal to 1.44 times natural logarithm of 0.512 over the natural logarithm of 0.64. And if you just plug it into a calculator, you'll see immediately that this is exactly equal to 2.16. Not approximately, it's actually exactly equal to 2.16. And that's answer E. Please remember, this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.